Okay, let's dive into this. Welcome back, everyone. Today's explainer takes us straight into the trenches of real-world software development with refactoring Haskell, enforcing the single responsibility principle. We're going to look at a pretty fascinating journey by a developer named Ang who had to rescue the XS2 ebook project. But before we look at Ang's specific problem, I want you to take a second and think about your own projects. How do you actually know when your code is getting, well, too cluttered? What are the warning signs you're looking for? It's really rare that a code base just breaks all at once, right? Usually it's the slow creep. You add a feature here, a quick fix there, and suddenly what used to be a clean, elegant file feels like a completely disorganized attic. It's a universal problem for us developers, and honestly, recognizing those symptoms early is half the battle. So, looking at Ang's notes on this X2 ebook project, they mentioned that as the project dragged on after so many moons, the codebase inevitably got bigger and a lot more cluttered. But here's the thing. Ang points out that this clutter isn't just some vague, nagging feeling. There are concrete, measurable symptoms that tell you a file has taken on way too much baggage. Ang specifically highlights two distinct indicators that a file in your project has essentially become bloated and desperately needs an intervention. And here are those two specific red flags. The first one, pretty obvious. It's the sheer size of the lines of code. When you're endlessly scrolling and scrolling just to find one basic function, yeah, that's a problem. But the second indicator Ang mentions is often way more telling, and that's a massive number of import statements sitting at the very top of the file. When a single module needs to import dozens of other libraries and dependencies just to run, it's practically screaming at you that it's trying to do too many different things. It's just totally tangled up in external processes. Section 1. Meet the monolithic module. And that brings us to the specific piece of architecture in the XS2 ebook project that was triggering these exact warning signs and, frankly, causing a lot of pain in the codebase. The whole problem centered around a big, monolithic module called xs2ebook.cli. Now, as the name suggests, this probably started out as a totally normal, simple place to handle command line interface tasks. But over time, it mutated. You can really think of this module like a multi-tool that was trying to do way too many jobs at once. Instead of just doing its one core thing really well, it just became the dumping ground for the application's core logic. And this brilliantly illustrates exactly how overwhelmed this single module really was. I mean, look at the four completely distinct tasks it was juggling. First, it was parsing command line arguments. Okay, sure, that makes sense for a CLI module. But then, step 2, it was also reading and validating input files. Step 3, it was orchestrating the entire executing pipeline. And step 4, it was literally responsible for opening the generated document in the user's default viewer application. That is an absolutely massive amount of unrelated responsibility crammed into one single file. Honestly, no wonder the import statements were out of control. Section 2. Single responsibility principle. So, recognizing that this module was doing way too much, Ang actually turned to an AI for some advice, and it suggested a classic, time-tested architectural solution to this specific problem: enforcing the single responsibility principle. The definition itself is straightforward, but the impact is huge. It basically states that a module should have one and only one distinct responsibility. It shouldn't be the parser, the validator, the orchestrator, and the document launcher all at the exact same time. Basically, if a file has more than one reason to change, it's doing too much. This principle is the absolute pivot point of our entire explainer today, because it's exactly how Ang solved the massive burden placed on that monolithic CLI module. Section 3. The refactored structure. Let's move to and see how this actually builds into the physical structure of the project. Because, theory is great, but seeing how this principle physically changes the files in a repository is where the real learning happens. So here's the contrast. In the old structure, absolutely everything was bottlenecked through that one monolithic CLI.hs file. But in the new refactored program structure under the src/x2ebook/directory, that workload has finally been distributed. The original CLI.hs was modified and stripped way down, and two brand new files were created to take on the remaining load: app.hs and input.hs. Let's break down exactly how those four massive original tasks got split up to honor the single responsibility principle. In this brand new setup, the app.hs module is now solely responsible for the app pipeline and orchestration. Just that. The modified CLI.hs has been stripped right back to its roots. It handles CLI options only. And finally, the new input.hs module takes over the I/O, the validation, and opening those generated files. And it's really important to note that these three highly specialized modules now live neatly alongside the existing focused files in the directory, like converter.hs, lexicon.hs, parser.hs, and types.hs. Everything finally has its place, and everything has one job. Section 4. Why this refactoring matters. So, the crucial point is, why actually go through all this effort? Refactoring takes time away from building cool new features, right? So there has to be a tangible payoff. Well, in Elling's notes, they highlight 3 distinct, hard evidence benefits of applying this principle to the Access to eBook project. The first massive benefit is the separation of concerns. Before this, if you wanted to change how the application executed its logic, you had to dig through all these command line parsing definitions and file validation code just to find what you were looking for. Now, those things are completely decoupled. The parsing definitions, the file I/O validations, and the execution logic exist in their own isolated bubbles. Changing one doesn't risk accidentally breaking the logic of another. It's so much safer. Now, what's really interesting about this is how the clean extraction directly impacts your day-to-day workflow as a developer. By breaking the monolith apart and drastically improve testability and reusability. Because the responsibilities are now completely isolated, other modules can just import the specific, targeted functions they need. For example, if another part of the program needs to validate an input file, it can just import input.hs. It's not forced to drag along all the heavy, unnecessary dependencies required for CLI parsing anymore. Testing just becomes an absolute breeze when you only have to test one isolated behavior at a time. And finally, we've got maintainability. By definition, the refactored modules are now smaller and just significantly easier to reason about. You can open app.hs and understand exactly what it does in seconds. But Eng points out a very specific technical advantage here too, which is reducing the compilation cascade. In Haskell, like in a lot of compiled languages, changing a massive file that everything else depends on forces the compiler to recompile huge chunks of your entire project. By isolating these components, when you make a change to a particular component, you only recompile what's strictly necessary. It saves time, it saves resources, and honestly, it keeps you in that flow state. Eng's journey with the X2B book project is just this perfect micro case study in why architectural principles exist in the first place. They aren't just dry academic theories, they solve very real, day-to-day frustrations that we all face. So I want to leave you with this provocative thought to consider today. Look at your own projects. What monolithic module in your codebase is trying to be a multi-tool right now, and how much time could you save by breaking it down? Thank you so much for joining me for this explainer. And hey, happy refactoring!